Every galaxy you have ever seen a picture of is spinning too fast. By the same rules that keep the planets in their orbits, the outer stars should have been flung off long ago. They are still there, and for 90 years, the best explanation anyone has is that something we cannot see is holding them in. This is how we know that, and how completely we have failed to find it. 1933. Fritz Zwicky is looking at the Coma cluster, a swarm of 1,000 galaxies held together by gravity. He measures how fast they are moving. Then he adds up all the light, converts it to mass, and asks whether that much mass can hold the swarm. It cannot, it is not even close. The galaxies are moving so fast the cluster should have scattered long ago. Zwicky names the missing ingredient Dunkelmaterie, dark matter. It is worth saying that his own number was wrong. He used an expansion rate about 8 times too high, which inflated the missing mass to 400 times the visible. Redo it properly and the answer is closer to 6 times, still missing, still most of the cluster. And then almost nobody follows it up, for 40 years. The person who made it impossible to ignore was Vera Rubin. In the 1970s, working with Kent Ford, she measured something much harder to argue with than a swarm of galaxies. She measured one galaxy spinning. Here is the prediction. Nearly all the light in a spiral galaxy is packed into the middle. So a star out at the edge should behave like Neptune, far from the mass, orbiting slowly. Speed should drop as you move outward. Here is what Rubin actually measured. The curve goes flat. Stars at the ragged outer edge are moving just as fast as stars near the center. There is only one way that happens. The mass has to keep piling up as you go outward, long after the light has run out. Galaxy after galaxy, the same answer, roughly 10 times more mass than the stars can account for. So the picture flips. The bright spiral is not the galaxy. The galaxy is a vast, roughly spherical cloud of invisible mass, and the stars are the glowing sediment settled at the bottom of it. Now, a rotation curve is an inference. You measure motion and reason backwards to mass. Can we weigh the invisible stuff more directly? We can. Mass bends space, and light has no choice but to follow the bend. Put enough mass in front of a distant galaxy, and its image smears into an arc, or closes into a complete ring. The shape of that arc tells you how much mass is doing the bending, and it assumes nothing about what the mass is made of. Do it for a cluster, and you get Zwicky's answer back, from completely different physics. But there is a way out of all of this, and it is not a silly one. Maybe there is no invisible matter. Maybe gravity itself behaves differently across distances this enormous, and the equation is simply wrong. That idea survived for decades. Then, in 2006, astronomers looked at this. 2 galaxy clusters that collided and passed straight through each other. In a collision like that, the stars barely notice. They are tiny, and the space between them is enormous, so both galaxy populations sail through untouched. The hot gas does not. Gas hits gas, drags, and gets stranded in the middle, and that gas is most of the ordinary matter here. So where is the mass? Lensing answers that, and the answer is not the middle. The mass sits out on the wings with the galaxies, cleanly separated from nearly all the ordinary matter. You cannot get that by rewriting gravity. Modified gravity has to put the extra pull where the ordinary matter is, and here the pull has walked away from it. Whatever is doing this is stuff, and it went through that collision almost without touching anything. There is one more line of evidence. It is the least intuitive, and it is the sharpest. This is the oldest light there is. The glow released when the cooling universe first turned transparent, about 380,000 years in. Those blotches are sound. Before that moment, the universe was a hot plasma, and pressure waves rang through it like a struck bell. Ordinary matter feels that pressure and gets pushed around by it. Dark matter does not, it only pulls. So the two leave different fingerprints in the pattern, and the relative heights of the peaks measure how much there is of each. It is the most precise measurement in cosmology, and it agrees with the spinning galaxies and the moving clusters and the bent light. So could dark matter simply be ordinary matter that happens not to glow? Cold gas, burnt-out stars, rogue planets? No, and this is the part people usually miss. In the first minutes after the Big Bang, hydrogen fused into helium and a trace of deuterium. How much deuterium survives depends sharply on how much ordinary matter was there to work with. We can still measure that leftover deuterium today, and it says the universe made about 5% of the critical density in ordinary matter. No more than that. The books on ordinary matter are closed. All of it is accounted for, and there is nowhere near enough of it to be dark matter. Which leaves the recipe for the universe looking like this. Everything you have ever seen, touched, or been made of, under 5%. Dark matter, about 26%, 5 times more than every ordinary thing put together. And the rest, about 68%, is dark energy, which is not dark matter's cousin. It is closer to its opposite, smooth and pushing space apart. So what is it? The honest answer: we have worked out what it is not with tremendous precision, and we have not worked out what it is. The serious candidates span a genuinely absurd range of masses, more than 50 orders of magnitude, end to end. At the heavy end, primordial black holes formed in the first instance of the universe rather than from dying stars. One narrow window is still open, and it is disputed. In the middle, WIMPs, weakly interacting massive particles, somewhere between the weight of 1 atom and 1,000 atoms. At the light end, axions, hundreds of millions of times lighter than an electron, and originally invented to fix a completely unrelated problem in nuclear physics. The WIMP was the favorite for 30 years, and it earned that. The numbers worked out almost too neatly. So we went looking. Tons of liquid xenon, a kilometer underground, chilled and shielded and watched for a single atom flinching away from something invisible. This is the map of that search. Mass across the bottom, and how strongly the particle would have to interact going up. Every year without a detection carves another slice away. Everything above these lines is now ruled out. They have caught nothing at all, not one particle in 30 years of looking. And there is a floor coming. Neutrinos from the sun and the atmosphere scatter in almost exactly the way a WIMP would. Once a detector is good enough to see those, they become a fog it has to see through. Not a wall, but the cheap part of this search is over. So what about that alternative? Modified gravity has not gone away, and it deserves a fair hearing. The main version is called MOND, and on Galaxies it is genuinely impressive. It predicts the shape of a rotation curve from the visible matter alone, using one new constant of nature, and it does it with less slack than dark matter needs. On that turf it is a real success, and it is still not explained. Scale up though, and it comes apart. It cannot account for the mass of galaxy clusters unless you add unseen mass, which rather gives the game away. It cannot reproduce the pattern in the oldest light, and it has no story at all for 2 clusters whose mass walked away from their gas. So the score stands: 1 win on Galaxies, 3 losses on everything larger. Which is where this leaves us, and I think the honesty is the interesting part. 5 independent lines of evidence: spinning galaxies, moving clusters, bent light, colliding clusters, and the oldest light in the sky. They were gathered by different people, using different instruments, over 90 years. They all land on the same amount of invisible mass. We know how it clumps, we know it does not glow, we know it barely touches anything. And after all of that, with detectors sensitive enough to notice a single atom twitch, nobody has ever held a piece of it. Most of the universe is still a rumor. We only ever hear it through gravity.